Again, as a generalized strategy, you're going to need to factor these guys. And they look tough. So the first guy isn't that bad. You get x comes out, and what are you left off with? 8x squared. Well, you know what? More than that comes out. Let me get my eraser out. I just noticed it. More than x, it's actually 2x, which makes it my life a lot easier. So what do you get over there? 4x squared minus 11x minus 3. And then I'm going to try to factor that. And what would that factor to? 2x. Let's see what else you get. 4x plus 1 and x minus 3. It's easy to say something. Let's see if it's true. Certainly, if I check the first line out, you get 8x cubed minus 22x squared minus 6x. That worked out beautifully. I'll erase this. Whoops, I went too quick with that. Let me check it. 4x times x is 4x squared. You get minus 12 plus 1, which is minus 11, and you do get minus 3. Things work out. I'll erase this now. I've checked everything I need in that first one. Now, I'm going to look at the second guy, and the first guy's done. There's nothing else to do about that. I'm looking at the second guy, and I'm also seeing something that might make my life a little bit easier, all right? So I'm going to factor out an x squared in that one, and what would you be left off with? Well, let's take a look. You'd be left off with 8x4 plus 6x cubed minus 11x squared minus 23x minus 5. Well, you know what? I'm still going to use the rational root theorem in this one. And what's interesting about it, kind of looking at it, I'm going to say that I'm looking for easy things. So the listing of roots would be the factors of 5, which would be 1 and 5. This is plus or minus, by the way. And the bottom would be what? Let's take a look at that. 1, 2, 4, and 8. Okay, let's go through this. They couldn't share this factor because that's not in the rational root list. Could they share this one? Yes. And why is that? It's in the list. What's in the list? Minus 1/4. So what I'm going to do is make an assumption. And by the way, I know assumptions can be bad sometimes. But I'm going to assume that this factor goes into that other polynomial. But they could share no other factor. Once I do this, I'm home free. Let me see if they share the factor. And I'll write this down for you. So 4x plus 1 divide into 8x4 plus 6x cubed minus 11x squared minus 23x minus 5. That would be 2x cubed. That would give me 8x4 plus 2x cubed, subtract, and I am hoping that this is going to go smoothly. What's the next one? But if it's doing smoothly, it's over anyway. So let's what do you get over here? Plus, let's see, x squared. What would you get there? 4x cubed plus x squared. That would be minus 12x squared minus 23x minus 5. Let's see, minus 3x. That would give you minus 12x squared minus 3x, subtract, minus 20x minus 5. And then I'm going to put down minus 5. What do you get? Minus 20x minus 5. Well, that's good news. So now I got this guy factored. What is going to be x squared? And then you get 4x plus 1. And then I get a cubic. And the cubic is going to be this over here. Now someone says, can you factor that cubic? Well, you know what? It's unimportant to me at this point. I'm not even going to bother looking at it. I'll tell you why. There's no way those two would share a factor. All right? There's no way. They couldn't share a factor. Rational root theorem would prevent that from occurring. So, I am now ready. Whoops, didn't mean to do that. I am now ready to write down my LCM. My LCM must contain the factor 4x plus 1. It must contain the factor of a 2. It must contain the factor of an x. How many, though? 2 of them. The maximum number of times occurs in any one factorization. Whoops, forgot to do that one. It must contain a factor of x minus 3. It must contain this cubic factor as well. 2x cubed plus x squared minus 3x minus 5. This is my committed LCM. Let's see if we got that. Got the 2x squared, 4x plus 1 I have, x minus 3, and 2x cubed plus x squared minus 3x. Yeah, things look great. All right? Thank you so much for paying attention.